Welcome to the second tutorial on looking at two triangles, but this time we're going to look at them in 3 dimensions. The measurements shown on the diagram were made by a surveyor to determine the line PQ, the distance from the top of the cliff to a point on the ground on the opposite side of a river. We need to determine that distance to the nearest meter. So the surveyor found that the length between Q and R is 55 meters. The angle of elevation between QR and RS, so from one side of the riverbank to the other at the bottom of the cliff, is 62 degrees. He also found that from QS and the angle of elevation from Q to the top of the cliff is 78 degrees. So that's what we know. We know that angle Q is 78 degrees, and that's on triangle PQS. We know that angle R is 62 degrees, and that's on triangle QRS. We also know that QR equals 55 meters. So how do we use this information to determine PQ? Well, the first thing we need to find is QS, because that is the common line between the triangles. So how do we do that? Let's use QRS triangle because we have a dimension there. So I have, if I look at QRS, we have 55, and that is 62 degrees. So in order to find this length here at QS, which trigonometric ratio can I use? I have opposite and adjacent. So I'm going to use the tan ratio. So tan of 62 opposite is my line QS over 55. So that means I need to multiply both sides times 55. So I have tan 62 degrees equals QS over 55. I can cancel out my 55s on the right-hand side. So that leaves me with 55 tan 62 equals QS. So if I solve that, you will get an answer for QS of 103.44. I'm just going to leave it with those dimensions. I'm going to put approximately because I truncated the answer. Now I'm going to look at my triangle QS and P. So now I know that QS is 103.44, and I have the angle of 78 degrees. And I need to find this line PQ. So I'm just going to highlight that in orange. This is the one I need to find. So which trigonometric ratio can I use to find PQ? Well, I have a hypotenuse and I have an adjacent side. So which one involves adjacent and hypotenuse? That's cosine. So just so you know what we're working on, PQ. So I'm going to have cosine of my angle, which is 78 degrees, equals my adjacent, 103.44, divided by PQ, because that's what we're going to find. If you'd like to change PQ to H or X, then feel free. I think I'll just leave it as H for now. So cos 78 degrees equals 103.44, and I'm going to call it H, like I have here. Multiply both sides by the h. Cos 78 degrees, then it equals the 103.44 over h times h. I can cross those two out. The other thing I have to do on the next round, I need to isolate my h. So I have h times cos 78 equals 103.44, and I need to move my cos to this right side. So I need to divide both sides by cos 78. So then obviously these cancel out. So h equals 103.44 divided by cos 78 degrees. And if you put that in your calculator, you will find that it comes out to 497.5, and they wanted the determined distance to be to the nearest meter. So that means it's approximately 498 meters.